What up, NL peeps? This is Mather, bringing you the math. Today we're going to work on solving a square root equations and other radical equations. Let's start with the square root. Just like we did our absolute value, we need to isolate our radicals so that we can work inside of them. So the first thing we're going to do is add 5 away from the radical. That'll leave us with 4x plus 1 equal to 5. Next, we need to get rid of the radical. Since the radical has an index of 2, the only way to get rid of it is to take it to the power of 2, because they're inverse operations. What I do to one side, I must do the other. The squared and the square root will cancel and leave me with just the radicand, and simplify my right side. Now is just like simplifying, solving an equation from algebra. We're going to subtract 1 and divide by 4. So I got x equals 6. And because we are solving using square roots, this can provide extraneous solutions. So what we're going to do is we're going to plug that 6 back in to see if it works or not. We'll start with doing 4 times 6 plus 1 underneath the square root and see if this subtracts 5 to give you 0. All right, 4 times 6 is 24 plus 1 is 25. And this would become 5 minus 5 is 0, which works. So x equals 6 is my solution. Now we're going to move into other radical equations. So here you can't see the radical because you don't see a radical symbol. But a power of 2/3 has an index of 3. So this is also a radical. It's a cube root. So we need to isolate my radical by dividing by 2. That'll give me x plus 3, still to the 2/3 power, equal to 4. Now, in the previous example, we had like a square root of something, and we had to take it to the power of 2 to get rid of it. Well, that was the same thing as, let's say, x to the 1/2. So we would have to take it to the power of 2 over 1. See the 2 over 1 right there. Sorry. So here, I need to inverse my radical. So I need to take it to the power of 3/2 so that my powers will cancel out and leave me with 1. What I do to one side, I must do to the other. That'll leave me with my radicand over here. The square root of 4 is 2, which is plus or minus 2. And then I'm still going to need to cube it. All right, from there, this breaks up into 2 separate equations. This will be x plus 3 equals a positive 8 from the positive 2 cubed, and an x plus 3 equal to negative 8, which was negative 2 times negative 2 times negative 2. We solve by using simple algebra. We subtract 3 from both sides, and I get x equal 5. And over here we subtract 3, and we get x equal negative 11. As before, we still need to check for extraneous solutions. So that's what we're going to do next. Let's check the x equal 5 first. All right, so order of operations, say we need to do 5 plus 3 first. And then we need to take it to the 2/3 power. Now, I'm a fan of always rooting first because it makes the number smaller and easier to work with mentally. So I'm going to do the cube root of 8 first and get 2, but I'm still going to have to square that. Then I'm going to get 4, and that works. So x equal 5 works. Now, let's try with the negative 11. And see if it comes out equal to 8 like before. So again, negative 11 plus 3 is going to give me a negative 8. I am then going to take the cube root of that, and that'll still be a negative, but it'll be a negative 2. Negative 2 squared becomes 4, and it does work out to 8. So those are my two solutions. Finally, we're going to come to radical equations that have multiple radicals. The key to this is you can't isolate both of them because the 4 is in the way. But what we're going to do is isolate the more complicated one. And I think the 5x plus 4 is the more complicated one. So we're going to isolate that by sending the radical of x to the other side. And I like to put my radical at the end so I don't accidentally think that the 4 is underneath the radical with it. But you can do it either way, commutative property of addition. Next, we need to get rid of the radical on the left side. So we're going to take it to a power of 2. Again, because the index is a 2. What I do to the left, I must do to the right. The power and root will cancel and leave me with just my radicand. Now this over here, a lot of people want to just square each of those, but that is 4 plus root of x times 4 plus root of x. So we're going to have to FOIL or grid that out. It's a binomial times a binomial. So we have to do a little extra work here. So I'm going to go ahead and FOIL this one out. This gives me 16. It'll give me a 4 root x from my outside and 4 root x from my inside. And then root x times root x is just a plain x. Continue to simplify. This will give me 16 plus 8 root x, because those are like terms, plus x. Now you'll notice on the left side that I have no other radical on the left, but now I have a radical on the right. So what are we going to do? We're going to isolate that radical. So we're going to subtract 16 over to here, subtract x over to here, and that'll give me 4x minus 12 equals 8 root x. Okay, now I could divide both sides by 8 to really isolate the radical, but if I divide by 8 to the other side, that's going to give me fractions, and I'm not a real fan of that. So I'm going to go ahead and leave it there. When something's being multiplied by the radical, we can handle them pretty easily. So we're going to go ahead and square this, and that means that I have to square this. So again, we're going to have to FOIL again. This time, instead of using FOIL, I'm going to go ahead and use the grid method that some of you prefer. So I went ahead and did the 4x minus 12 on the top and the 4x minus 12 on the side. And then I went ahead and multiplied all those out in the boxes. And that would have given me 16x squared minus 96x plus 144. And again, on the right side, it would be 8 root x times 8 root x, which is 64x. Okay, we need to get everything equal to 0 since I have a quadratic equation. And that would bring the 64 this direction. So it'll end up giving us 16x squared minus 160x plus 144 equals 0. Now this example is a little bit more intense with the math. Numbers are getting pretty big, but it's still factorable. Just like we normally would, we get it all equal to 0, and then we factor it. I can take out a 16 out of everything, and that'll give me x squared minus 10x plus 9. And then I'm going to divide by 16, and also give me 0 on the right, so 16 goes away. Let's go ahead and factor this guy. Multiplies to get 9 and adds to get 10. 9 and 1 signs are the same, both are negative. So I got x equal 9 and x equal 1. We are going to have to check those, so that's our next step. Remember to check extraneous, we have to plug each one back in. So we'll start with 9. We'll throw 9 into the equation and see if we can get the same answer of 4. 9 times 5 is 45. 45 plus 4 is 49. The square root of 9 is 3. Go ahead and do that. And the square root of square root of 49 is 7. And 7 minus 3 is 4. So 9 is a solution. Now we need to check 1. So we'll go ahead and go over here, and we'll do 5 times 1. And see if that comes out to be 4. 5 times 1 is 5. 5 plus 4 is 9. Square root of 1 is 1. And the square root of 9 is 3. Is 3 minus 1 equal to 4? No, it's not. So this one is extraneous. Again, this one is a little more intense of an example, but just make sure that you isolate the more complicated one. And if you end up foiling with a radical, make sure that you, or sorry, if you won't end up multiplying with a radical, make sure you foil. All right, you should be able to try your own on the assignment on 6-5. Good luck.